Hello, welcome to Irodov problem series by UNS classes. Today we are going to solve the third problem from Problems in General Physics by I. Irodov. See the question. A car starts moving rectilinearly, first with an acceleration w is equal to 5 meter per second square. The initial velocity is equal to 0 given in the problem. Then uniformly and finally decelerating at the same rate w comes to a stop. The total time of motion is equal to tau is equal to 25 seconds. The average velocity during that time is equal to 72 km per hour. How long does the car move uniformly? Is a very good question. Let us see the situation. Using a velocity time graph, I'll explain the situation. Assume that you have a velocity time graph like this. Say, initially, the car is accelerating at a constant rate. That means you have a constant positive slope. Then, for some amount of time, the body is accelerating. The car is accelerating. Then, car is moving in a uniform velocity. Uniform velocity means velocity is not changing with respect to time. Remember, this graph is a velocity time graph. Okay, velocity time graph. Now, after some time, that is decelerating at the same rate and coming to rest. Okay, so now we can say the same slope, but negative will be there. The same rate that is going to decelerate. We can split this into two different regions, not total three different regions. See, there's a first region. Okay, the second region is given. Fine. Now assume that a certain amount of time, delta t is the time which the body or the car traveled with uniform velocity. This time we can find out how to find out that the total time from 0 to this point, the entire process is given tau. How much is tau? Tau is given as 25 seconds. See, we can easily find out that tau minus delta t. What is tau minus delta t? If I am taking the difference tau minus delta t, you will get this time plus this time. Now one more thing, if you are accelerating from 0 to a maximum velocity, you know that the time taken is going to be, let it be t1 time, exactly the same, or t time. So exactly the same time the body will take to decelerate from that velocity to 0. That is the logic. So we can find out the time. This time we can find out. The total time during the acceleration is tau minus delta t divided by 2. Okay, this is the time for acceleration as well as deceleration, and delta t is the time during body was covering in a uniform velocity. Fine. Here we can find out the maximum velocity. V is equal to u plus at. U is equal to 0 because it's starting from rest. So maximum velocity is equal to w multiplied by t. How much is the time? Tau minus delta t divided by 2. Similarly, we can find out the displacement. What is the displacement equation? S is equal to ut plus half at square. You know that again ut part will be vanishing because initial velocity is equal to 0. Now we can write down we can find out the displacement during the acceleration. So displacement is equal to half multiplied by w multiplied by t square. How much is time? Tau minus delta t divided by 2 the whole square. Now, see, the same amount of displacement will be there during deceleration because we are reaching maximum velocity this much. From there, we are moving to 0 again at the same rate w. We can say that this is S1 and S3 also we can write down because, same deceleration. So, tau minus delta t divided by 2 the whole square. See, this part, you can say that this part is having a displacement of S1, this is S2 and S3. Okay, so S1 and S3 should be same, and we can find out S2 very easily. So S2, we know the velocity, constant velocity is equal to, or displacement is equal to velocity multiplied by time. So S2 we can find out. S2 is nothing but w multiplied by tau minus delta t divided by 2 multiplied by delta t. Total displacement is, we can say S total is equal to S1 plus S2 plus S3. So each values we can substitute. See, S1 plus S3 we can add together, we can write down like 2 times half multiplied by W into tau minus delta T divided by 2 the whole square, okay, plus displacement during the uniform motion. How much is that? W into tau minus delta T by 2 multiplied by delta T. Let us find out the total displacement. Because you know we have the average velocity. Average velocity is total displacement by total time. We have average velocity value which is 72 km per hour and total time 25 seconds is given. So we have to solve this and find out the total value of displacement. St is equal to, this 2 can be cancelled. Let us take W common. So W common and remaining how much is there? Tau square minus 2 tau delta T plus delta T the whole square divided by 4 plus tau delta T minus delta T whole square divided by 2. Fine. Now, we can do one thing, we can multiply with 4, okay. Both sides will, I mean this part also and this part also will multiply by 4. So, I am dividing here by 4 and multiplying here by 4. Fine. So, then you are expanding again. See, W by 4, total displacement is equal to W by 4 multiplied by, so this 4 will be cancelled out. So, tau square minus 2 tau delta T plus delta T whole square. This 1 2 will be cancelled out. So, we will get plus 2 tau delta T minus 2 delta T square. Fine. So, we can see 2 tau delta T is there, 2 tau delta T will cancel out and delta T square minus 2 delta T square. So, you will finally get W by 4 multiplied by total displacement is equal to W by 4 multiplied by tau square minus delta T square. Fine. See, total displacement divided by total time total, okay, time total is equal to V average. Wow, how much is V average given in the problem? V average is 72 km per hour. So, that can be converted into meter per second. How to do that? 72 multiplied by 5 by 18 which is equal to 20 meter per second because acceleration is given in SI unit. So, we can substitute everything now. So, this is the expression finally W by 4. So, let us try to substitute everything. See, total displacement by time is equal, or we can say total displacement is equal to total time multiplied by V average. We can use that. Let us go to the next page. W by 4 multiplied by tau square minus delta T square is going to be equal to 20 multiplied by 25 because 25 second and 20 meter per second. W value is 5 units, 5 meter per second square. 5 by 4 multiplied by T square, 25 square. How much is that? 625 minus delta T square is equal to 20 multiplied by 25. See, this 5 can be cancelled out. See, 5 and 1 5 will come here. So, how much is the final answer? You can see that 625 minus delta T square is going to be equal to 20 multiplied by 5 multiplied by 4 which is equal to 400. We can say that 625 minus 400 is equal to delta T square. How much is that answer? You can say that delta T square is equal to 225 or delta T is equal to under root of 225. How much is the answer? 15 seconds. What do you mean by that? So, the body will be moving with a uniform velocity for 15 seconds. See, this is the idea. So, here from here to here if you are measuring the time, that is going to be 15 seconds. I hope all of you understood this solution.